So today we are going to see swipe Prolog. Okay, your experiment number 8 is expert system using Prolog. Okay, so the title of the experiment is expert system using Prolog. Aim of the experiment is designing expert system using Prolog. Okay, and then in the theory section you are going to write about the swipe Prolog interface, which I am going to show you. Okay, you are going to write about the swipe Prolog interface, which I am going to show you, and you will have to paste some snapshots how interface looks and how you can write a simple program. Then in the theory I will be also giving some questions. Okay, and then in theory you can explain how swipe Prolog works. Okay, for some people I have already taught that it works, it uses something called as forward chaining and backward chaining, and there is unification that is used, that is matching, and that's how it finds out the answer. All this we will do today. And besides this, you will now in the implementation part, all those questions which I have given, right? So question 1, question 2, question 3, you will have to type those questions in English, and then you will have to write the program which I am showing. Those programs you will have to write, and accordingly the queries that you need to ask, you ask and get the snapshot of the output. And at the end, the last, I think I will not be able to finish that part. I will show you one this implementation of expert system, medical diagnosis system, where the system will ask you regarding different symptoms, and based on those symptoms the system will diagnose that you have got so and so disease. Okay, maybe that short video I can share later because it will take less time, but I think this basics need to be understood more, right? So now what is Prolog? The first thing is, what is Prolog? Prolog is a declarative language. Prolog is not like a C programming language or Java programming language. It is not used for mathematical computations. It is used for logical programming. Now there are also other counterparts. For example, there is another language called Lisp, LISP, that is used for AI along with Prolog, and now Python is also going a long way. People use Python also for AI extensively, right? Now, before we actually know about the language, let's see what are the different constructs which are available in Prolog. Okay, now we have come from predicate logic background. Okay, so we know that in predicate logic there are certain operators. For example, you have this, and this is called as conjunction. You have this is called as disjunction. Then you have this, or sometimes you write like this also, or sometimes you write something raised to bar. So this is called as negation. And finally you have something called as, this is called as implication. Okay, and the implication is written like this: alpha implies beta. So which means that the new facts can be inferred. Okay, sorry. Okay, implication means alpha implies beta means if I already know, okay, I already know that alpha is true, I can easily infer the new fact is beta, right? So this is the old or known fact. This is the old or the known fact, and if this old fact is true, I can infer a new fact. Correct? Now, how do we have the same thing in Prolog? Now, before I start with Prolog, the software that we are going to use it's a open source commercial version, and that is called as SWI Prolog. Okay, SWI, SWI Prolog. Okay, now conjunction and predicate logic. In Prolog you have comma. Comma means conjunction. Disjunction or semicolon means disjunction. Negation, there is a predicate called as not predicate. So whatever you write inside this not predicate, all this is negated. Okay. Now implication, Prolog does not have implication, but it has a symbol colon and this symbol is called as if and only if. Okay. So now when I write alpha if and only if beta, you know what it means? The new fact alpha can be inferred if and only if we know that the old fact beta is true. Now you compare this predicate logic's implication and the one that we have in SWI Prolog. What you have written here is old implies new, and here it is new if and only if old is true. Exactly opposite, ulta. Okay. So these are the major constructs in SWI Prolog. Now besides this, there are some other predicates that we are going to see. There is something called as exclamation mark, and this is called as cut predicate. See when it is used. Besides this, there is a predicate that enables you to write something on the computer screen. This is called as write predicate. There is a predicate called as read predicate, which enables you to read something from the keyboard. And there is a predicate called as NL, which stands for new line predicate. So these are the support predicates, extra predicates that we are going to see. Now besides this, there is something called as green cut, there is something called as red cut and all. Okay, but we are not going to learn those things because Prolog as such is a big subject. You can introduce Prolog as one full module, unit, and we are just learning basics. So I will not include. So these are the basic constructs in SWI Prolog that you need to learn. So in the theory part of your experiment number 8, you need to explain all these operators. Okay. More information for writing you can find on a textbook called as Rich and Knight, Artificial Intelligence by Rich and Knight. This is a textbook that is also mentioned as a reference book in your syllabus. Rich and Knight textbook is available in the library. Also you will get a PDF. That does not mean that you have to read textbook and I will not teach. I will teach only, but if you want to write with proper words, you can go through that textbook, the introduction. Same thing I will teach here. Or you can listen to me and you can write accordingly. Both ways. Fine. So now, having seen what are the basic constructs available in SWI Prolog, let's see the interface of SWI Prolog. Okay. So when you install SWI Prolog, can you see this orange color owl? Right? This is a symbol of SWI Prolog. Okay, shortcut. So you click here, and what opens is, this is called as SWI Prolog shell. Now if people have come from Python and you have used Python idle, this is exactly similar to that. This is a shell where you can ask the queries to the Prolog system. This is a shell where you can ask the queries to the Prolog system so that it gives you output. But unlike Python, you will not be writing programs in this shell, rather programs will be written in Python editor. Okay. So now let's create a new program. So file, I say new, and when I say file new, it will open, it will tell you to specify the location. Let's say on desktop I create a new folder. Okay, say my Prolog, and in this my Prolog I will create my program. Now like Python, in Python the extension of Python program is .py, extension of Prolog program is .pl, remember this, .pl. But in SWI Prolog it will by default take this as Python source, so you don't have to write the program name as program.pl. Okay, so my first program I'll write it as first, so it will be first.pl actually, and I say save. Once I do this, the editor is going to get opened, and this is a place where you're going to write your program. Okay, so now I want each one of you to take this particular problem that I can solve this using Prolog. Okay, so you can take this sentences. Wait, yes, you can take this sentences. First sentence, cakes are delicious. Oh, color change. Second sentence, pastries are delicious. Third sentence, what do you say? Anything? Pickles are delicious. Fourth sentence, pickles are spicy. Okay. Fifth sentence, John likes delicious food. Sixth sentence, Rita likes delicious and spicy food. Okay. So these are the sentences. Okay. Now let's see how these sentences can be entered into the Prolog system. Okay. So you can just tell me one by one each sentence as I am asking. The first sentence is cakes are delicious. So I'll go to my editor and I will write delicious cakes. Now every programming language has some stopping criteria at the end of the sentence. For example, in C++, it is semicolon, right? Similarly, in Python, every statement of the Python should end with a period or dot. Fine. So when I write delicious cakes, this is a predicate that I have written, right? Cakes are delicious. Delicious is a special property of an object called as cake. After this, I press dot and you see the color changing. You can see that delicious, its color changed to bold red, which means that Prolog system is now recognized that delicious is a predicate and it is recognized by the knowledge base. Okay. What is the second sentence? Cakes are delicious. What is the second sentence? Pastries are delicious and pickles are delicious, the third sentence. So I'll write delicious pastries and pickles are also delicious. Further, I have given pickles are spicy, correct? Spicy pickles. And the next sentence which I have given is John likes delicious food. Okay. Now, when I say John likes delicious food, if it is a if it is in the predicate logic, I have written that sentence. John likes delicious food. You were written like this: for all x, if x is food, or for all x, x is food, and likes John, comma x. Okay. But what is a better way of writing this? So it means that if at all there is a food item available, that means John will like it. So there is an inference in this sentence actually. I have written this as a fact, but actually there is an inference in this sentence, because John likes, if it was John likes food, fine, but John likes only delicious food. Okay. So if x is food, or you can say if x is delicious, not food, if x is delicious, okay, then instead of writing it as a fact, you can write this as an implication. If x is a delicious, implies likes John, that x. Correct? Why I can't write it in the first manner? I could have written, no, for all x, if x is delicious, for all x, x is delicious and likes John x. Instead of implication, if I write and, it is only the fact that you are representing. But tomorrow if a query is asked to the system, what food John likes, will it be able to answer this question? No. But if I write like this, if x is delicious, implies John likes it. So for such implied responses, I mean for such implied or for such implications, the Prolog system will be is able to explain it in a better way. Okay. Prolog system will be able to explain you in a better way. It is going to tell you John likes particular thing. Why? Because it is delicious, and that's why I have taken this as implication in predicate logic. Okay. Now note that in predicate logic, this is old fact, because it is already told that there are few items which are already delicious. They will be there in the knowledge base. So this is the old fact, and this old fact implies something called as new. Now I call this as a new fact because likes predicate is, so far it is not there in the knowledge base, right? So how will I write this in SWI Prolog? Okay, alpha implies beta in predicate logic can be written as is equivalent to beta if and only if alpha in Prolog. Okay, here alpha was the old fact, beta is the new fact. In Prolog, new fact will always come on the left hand side, and already existing facts, supporting facts for this beta to be true, are supposed to be there on the right hand side. This is in Prolog, this is in predicate logic. So now let's continue. Okay, so likes John x. Now students, see, while teaching in the class, although I was using quantifiers, universal quantifiers, existential quantifiers, and then there are variables that represent those quantifiers. In class I did not restrict you, I did not say that okay, variables you specify in capital letters and all. I said it is if you use small, because that was theory. Prolog is a programming language. The syntax of Prolog is such that whenever you write any word starting with a capital alphabet, or whenever you write an alphabet that is capital alphabet, Prolog system considers that as a variable and not a value. Okay. So that's why the X which I have written over here, this is capital X. Okay. So John likes X. This is a new fact that I can infer if and only if that X should be delicious, already known to be delicious in the knowledge base. Now when I press dot here, okay, Prolog system tells you that it has just registered spicy and likes, which are the predicates in the knowledge base. It has registered them, and you see the X which I have written here, its color is red color, not in bold, which tells you that it's a variable. What is the last sentence? What is the last? Rita likes delicious and spicy food. So likes Rita, comma y, such that if and only if that y is delicious, and means comma, that y is also spicy. So this is how, using the interface, I have written a simple Prolog program whose name is first.pl. Okay. Now you can save, you can use control plus S to save the program. Okay. So you go to file and you can say save buffer, the program is saved. Now you can go to compile and say compile buffer, or you can just press control B, that also will work. Okay. So compile buffer. When I say compile, nothing happened, right? Okay. So I have to go to the Prolog shell here, and the Prolog shell, it now tells me that first.pl, this program is compiled in 0.00. Now the queries that you are going to ask, you are going to fire the queries over here. Let's ask the very first query. Which food items are delicious? Okay. So I will write here, I am asking the query, I will say delicious what, where what is a variable. Why? Because I have started with capital W. You can even write the variable, the full word in the block letters, that is fine. Okay. And after asking the query, don't forget to press dot and press enter. So now it says what equal to cakes, that means it says cakes are delicious. But my question to you is, only cakes are delicious? There are more food items also that we specified which are delicious. Okay. Now what I do, I press semicolon here, and after pressing semicolon, is now what equal to pastries. I again press semicolon here, and now it says what equal to pickles and nothing else. I just told you that semicolon is used for or disjunction, but this semicolon is also overloaded, so that whenever in this shell, execution shell, whenever you are going to use semicolon, you know what it means? It means that whatever answer that you have just now given, I reject that answer and I plead to give me, I plead you that give me a new answer or an alternate answer. So that semicolon means you are asking the Prolog system to give any other alternate answer. Okay. But when you are going to use this semicolon within the Prolog statements, it would mean disjunction. Whenever you are going to use it in the shell like this in queries, it means you are asking for other alternate answers. Okay. So this is how Prolog works. Okay. Let's fire the second query. Now let's ask, who likes spicy food? Okay. So likes who Okay, one sec. I'll just go back to this because I need to talk about this. See, Rita, okay, Rita likes delicious and spicy food, right? What query I am asking? I am asking who likes delicious and spicy food. Okay, so let's see how I write this query. Okay, likes who, comma, let's see the statement. Okay, the query itself is written like this. There is no see, whenever you are talking about left hand side and right hand side, okay, now you want to ask this query, who likes spicy and delicious food? So who means you are going to write, likes x comma y, okay, but the query that I have written here is the one wherein here there is no variable is only used here. So accordingly I will have to ask the query. Okay, so let's ask this way, what food Rita likes? What food Rita likes? Okay, so I'll just write this query here, likes Rita what? I have changed the query because I have written the rules like that. If I want to write the other way around, who and delicious, I will have to change the query in the sentence in the program. Okay. So then, what equal to pickles? Now here it did not wait for you to press semicolon, because there is only one food item that is spicy as well as delicious, and that is pickles. Okay. Now how Prolog system does this? How Prolog system runs this query? Okay, let me explain you that code. So this is our program. This is our program, and the query which we just asked, the query that I asked was, what food items are delicious? Delicious what? This was a query. Now I will tell you how the Prolog executes the code. Okay, so the query is delicious what? So let's see. Okay, so the query here is delicious what? This is a query. Now since the query that you asked is delicious what, Prolog system would try to give this answer as true. Okay, now for this delicious what to be true, this has to be mapped, or this has to be matched to an already existing fact in the knowledge base, correct? So the unification or the matching procedure, it starts execution over here, and it compares this predicate delicious with already existing predicates in the knowledge base, just to find out whether there is a match. So it finds the first predicate in the knowledge base, and that is delicious 6, right? The unification algorithm says that in order to make this thing true, it is possible only if I can have a match of this one with an existing predicate in the knowledge base. The first predicate over here, it matches with this delicious and delicious, and matching can happen only if the unification gives the substitution theta as theta wherever there is what should be replaced with cakes. Agreed? So it replaces what with cakes, and by doing this, unification algorithm finds that yes, there is a match between delicious and delicious here. So with the value of what as cakes, the answer happens to be true. Correct? As a result, it gives the answer as what equal to kicks. Okay? So when you saw the first thing here, when you saw the first thing over here, it told you what equal to kicks. Correct? This is the answer given by the unification algorithm. The theta value was substituted. But then after this, you pressed a semicolon. Okay, after this you pressed a semicolon, and when you pressed a semicolon, something else happened. And what is it? So by pressing semicolon, you are telling that I ignore the answer that you have given me, give me a different answer. Okay, so now when you press a semicolon here, what happens? Okay, when you press a semicolon, okay, it means that the answer that was given to you, that is what equal to kx, is rejected. So the value of what, the value that in what is rolled back. Okay, so what is the value that is kx, and unification algorithm is again it tries to match delicious not with the first one, but now with the second one. It will ignore this one because kx is already rejected by you. Correct? So it will go with the second one, and then what else can be delicious? So it gives you the substitution theta over here. Okay, and what is the theta? Matching this thing, the query that you asked, it can give you answer true only if what is substituted with pastries. This is the theta that it gives you. Okay, so when what is replaced with pastries, the answer to your query becomes true. So that substitution is given as answer, and that is how here you saw after pressing colon, you saw that next it printed what equal to pastries, and the same process gets repeated. Okay, and this is how it executes the queries. Now, since I am talking about the swipe prolog interface, let me tell you another thing. Now that you have written the program, let me close this program. Quit. Now there is another way. There is another option called as consult. Let's say 2 days back you had written the program. You know what that program does, and you know what query you need to already fire. Okay. In that case, you will not waste time in opening the program. Rather, there is something called as consult. That means you are consulting the Prolog system that you are designing, asking a particular query directly. So just see what happens now. I go to file and I say consult. When I say consult, it opens an interface wherein you can select which program you want to consult. Now this is the program that we have written. So I click and I say open. Notice that your program has not been opened. The program has directly compiled. Can you see there? First.pl compiled 7 clauses. But was your program opened again in the editor? No. So this is actually something called as consult action. So you are directly consulting the program. You are not expecting to open the program. You are expecting to directly fire the query. You know the inside out of the program. Okay. So you can ask the query here only. Say spicy X. You are asking what is spicy, and it gives you X equal to pickles. Pickles are spicy. Got it? Many times you need to change or edit your program. That time you don't use consult. You use another option, and that option is this. Go to file and go to edit. And now you open your program in edit mode so that you can edit your. So go to first. See, now you can open the program. You can change or edit your code, and then you can execute the program as it is. Now, don't think that I taught you a Prolog program. All was introduction to the interface of swipe Prolog. Although I will give you a program which you can write and you can ask those queries. Clear? Now, take down another one. Take down another one. Take down. Represent the following sentences. Represent the following sentences in Prolog system. Please write. Represent the following sentences in Prolog system. First sentence. Peter, Alex and John are students. Peter, Alex and John are students. Okay. Next question. The student who studies hard, passes the exam. John did not study hard. Peter and Alex studied hard. Ask the following queries to the Prolog system. Ask the following queries to the Prolog system. Will John clear the exam? Okay. So how will you write this program? Now students, remember the first sentence that I have given you, Peter, John, Alex are students. Comma means end. So whenever such thing happens, you will have to write a separate predicate, separate sentence for it, saying that Peter is a student, John is a student, Alex is a student. Okay. So how will you write this? So tell me, student Peter. So Peter is a student, John is a student, Alex is a student. Then next, what is the question? Student who studies hard passes the exam. Okay. Passes X capital. If and only if that X should be a student and studies hard X dot. Now when you write this sentences, the order, purposely I have given you this, because see, now that you have written studies underscore hard X, can you see that in red color? It's not bold red color, because at this moment it is not finding an already existing predicate in the knowledge base. What I taught you, on the right hand side all the predicates should be there, on the left hand side new predicate should be there. Now see the next sentence. Who studied hard? John did not study hard, but who studied hard? Peter and Alex, no? So I have to include the sentences on top of this. Okay. Studies hard, studies hard, Peter, no? Studies hard. Who is the second? Alex. And another sentence, John did not study hard, correct? So I will first write studied hard John, and then I will negate this studies hard John, and will negate this by writing a not predicate outside, not and dot. So this is how I can negate a given predicate. So purposely I give this so that I can show you the not predicate. Yes, Kezia. Okay. And then I will add more things to this so that I can show you semicolon also or later. Okay. So this is a query that this is a program. I will save this program. And now what query is to be asked? What query? Okay. Remember students, clears exam. In place of that I have written passes, right? So you need to ask the query called as who cleared exam. You are going to ask passes exam who. Got it? Otherwise you change here, in place of passes you write cleared exam X. Okay. Like this, save it, and now ask. Now I'll ask the first question, did John clear exam? What answer it gives me? It should have given the answer as false. Huh? It's compiled already. Sorry. Okay, I did compile the program, so I'll say buffer. Compile. Okay. Just check, I have said compile, but it tells me something here, and this is the same error that I wanted to tell you, but that was a different error here because it was not compiled. See, foreign predicate did not clear expression, error, and where is the error? See, file users me desktop my Prolog with respect to context G2075, okay, it says unexpected end of the clause. It says unexpected end of the clause. Now you go back here. For every of the clause you have written at the end. For every clause you have written dot at the end. Then still why it is telling you unexpected end of the clause? Check. Can you see that yellow colored thing for not? In the in more examples we would use not. Remember this. Now whenever I say cleared exam John and outside I put not, not itself becomes a new predicate. Got it? So if you ask a query, John did not clear exam, such kind of query, it will not be able to give you answer. But if you ask the query, not John cleared exam, then it might give you the answer. But at first place, this not predicate, it should not be used in an isolated way. It has to be always used in with colon and dash. That's called only. If you use it in the and then we'll see how we can then represent it. I say save buffer. Now it compiles. Now it compiles. Now ask the query. Cleared exam. Who? Peter and Alex. Now you want to find out whether John cleared exam. I have removed that not clause. So I am not telling the Prolog system that those who are not mentioned as cleared exam, actually they have not cleared exam. That's a common sense, right? But common sense reasoning is there. Predicate logic has it? No. Same thing should reflect. So I say cleared exam John. I am asking whether this thing is true or not. Press dot. Did it give you the answer as false? In class we saw predicate logic does not have common sense reasoning. We have to add new things. But when it comes to Prolog, you remember there is something called as closed world assumption that I mentioned once in the class. Everything that is not mentioned is not true. And Prolog does this. Prolog has this closed world assumption. So whatever which is not mentioned is assumed to be not there. So is this not the alternative of saying that John did not clear exam? Then at first place, why sir wrote that not to confuse us? I wrote that not because for semester exam practical also you are going to use not this way, because it is available. Don't use it this way. Not predicate has to be used with left and right side only. Keep this in mind. So sentence that not negation, it's an isolated sentence, molecular sentence, better not to mention it. That will be false only. Yaad urtili? Now this program you don't write for practicals. The first one you can write. I have given the programs. Okay, Priya relishes coffee and all those same programs. I can give you the same program. Now what you need to write for practicals in the file, the next program is this. Take down. Now I want to demonstrate semicolon. So that same program which I controversial program. Okay, take down. Peter, Alex and John are men. Peter, Alex and John are men. Okay, Jane, Ashley and Tina are women. Jane, Ashley and Tina are women. Okay. John likes Jane. You can substitute whichever names that you want. John likes Jane. Tina is wealthy. It is a known fact that man only weds a woman whom he likes or who is wealthy. Man only weds a woman whom he likes or who is wealthy. Can you try out these sentences? Okay, before you try, or how will you try? On book you can try. Okay. First two sentences, there is comma, right? John, comma, Peter, comma, Alex. So you should treat them as separate sentences. Similarly, woman also, first two sentences, and write as it is. Okay. You do it on your book, I will do here. Okay. I want you all to see the last sentence that I am writing. Okay. Man only likes woman, man only weds woman whom he likes or who is wealthy, right? So weds is a new predicate, new fact. Weds x comma y if and only if x should be man and y should be woman and the x likes y or y is wealthy. Please see on the screen what I have written here. X weds y if x is known to be man, y is known to be woman, and x likes y. Either this full thing is true, or if this left hand side part is not true, then at least y is wealthy. In that case, that particular man, whoever it is, will wed that y who is woman. Okay. Prolog does not have a formal if else structure, but using this semicolon you actually can exhibit this if else. If not the first part, it will go to the second part and so on. Okay. Now let's run this. Let's ask the query. Okay, the query that you need to ask is what? Take down the query that you need to ask. First query: who weds Tina? Okay. And second query: who weds whom? First query: who weds Tina? Second query: who weds whom? Okay. I want to trace this program, so I am asking this query. So I will go here. Okay, I have to save the program first. Save buffer. I compile the program. Yes. Okay. Okay, I asked the first query, weds who weds Tina. What error it gives me? Wait, let me open the program, file, edit. Oh, my program is not saved. Okay, so now you ask the query, who weds Tina? Answer is Alex. Okay, ask the question, Alex likes Tina? No, it is only who likes Jane? John, and nobody else likes any other woman. Still, it is Alex who weds Tina. If I press semicolon, Peter also weds Tina. Why? Peter also does not like Tina, but he weds Tina because, press semicolon. John also weds Tina. Now John was liking Jane, still he weds Tina. Okay. Press semicolon. It gives you true. I want you all to focus on the last thing. Who is not important. What is important is that last thing that prints true. Why true? You got what I am saying? Those three people who are listed, fine, because alternative is there, but then it finally it prints true. Why that true? And why not false? Okay. So if you trace this program, if you trace, okay. Now, what is the query that you asked? What is the query that you asked? Weds who Tina? This was a query that you asked, correct? Who weds Tina? Now, see what happened. Now, Prolog system, in order to make this true, it tries to, unification algorithm tries to match this with an already existing fact in the knowledge base. Now, it tries to match weds with the first one, men, no match. then the second one, no match, third one, no match. Okay, so it rejects all this and finally it comes to this one, weds. Okay, so now what unification algorithm says, in order to make this query true, it has to be matched with an already existing fact in the knowledge base. It found a member. Here also there is weds keyword, here also there is weds keyword. But there are two parameters and also there are two parameters. But it cannot directly give you the answer true because this is not a lone fact, rather this is a rule. Correct? Left hand side and right hand side is there. So for this thing to be true, the new fact to be true, it is possible only if the entire right hand side finally gives the answer true. Only then I can say that this is true, and once this is true, it can give you the answer true. Correct? Now remember that in class, apart from resolution, we have studied two things. One is called as forward chaining, second is called as backward chaining, and I just told you Prolog uses both approaches. Prolog uses forward chaining because as it goes in a forward direction, whatever values which are assumed to the variables, they are carried forward. Backward chaining because when it rolls back or when it takes the values back, okay, either the values are erased as it goes back, and suppose it gets success on the right hand side, as it comes back, backward direction, and if the thing ultimately gives the answer true, then as it comes back with success, it will carry that value so that it can store that on the left hand side. So forward direction and backward direction. Okay, now so let's trace this and see. So I just told you that in order to match this, it comes to this one here. Now for this thing to be true, the entire right hand side has to be true. Okay, but you know how function call gets mapped to the function code, right? So at this moment it says this one and this one can match provided the right hand side matches. At that moment, whatever values which are there in who, the same values are supposed to be there in x. This is the substitution that is given by the unification function. Similarly, whatever values that you are going to finally get in y are same values that are there in the Tina. And as a result, initially, even before going to the right hand side, variable y gets the value Tina. Correct? Unification algorithm, when it does the matching here and here, the substitution that it gives is, it gives two substitution. First one is theta 1, that is x can be replaced with who. This is the first substitution, and theta 2 is nothing but y can be replaced with Tina. Only then there is a match between this one and this one. But as of now, it cannot give you the answer as true, because unless and until it proves that this left hand side is true, it cannot give the answer. And the validity of this left hand side, it depends on what is the answer on the right hand side. If right hand side full thing returns true, only then this left hand side will be true. Okay. So now the Prolog goes in the forward direction, forward mapping, and as it goes in the forward direction, it carries forward the value of y along with it, which is Tina. Now it goes to the right hand side first parameter, and now it tries to make this main x true. So another instance of unification algorithm runs that tries to match this main x with already established fact in the knowledge base, so that this can be true. So now it tries to match this one with the first fact in the knowledge base, and unification algorithm now gives theta as main x and main lx can be matched provided x is substituted with lx. Agreed? So it substitutes x with lx, and this part turns out to be true. But it is it the only element on the right hand side? No, there are more elements. because there is comma here. Comma means and. That means this one should be true, and this one should be true, and this one should be true. I mean, at least both of these should be true, either, or if not true, then only this one should be true. Only then the right hand side can become true, and then you claim that the left hand side is true. Okay. So now, as it goes forward in the forward direction, it carries along with it two things. One, the value of y, which is t naught, and second, the value of x, which is Lx. Now it substitutes this y with t naught, because it has carried forward this value. This is called as forward mapping. And now unification algorithm, third instance of unification algorithm, tries to make this true. Okay, so it tries to match woman t naught with already existing facts in the knowledge base. Now first one cannot match, second one cannot match, third it tries to match this, cannot match, not match, yes, here it matches. So with the value of y as t naught, this one also matches. Wait, okay. So with the value of x as who? Lx, of y as t naught, both the elements on the right hand side has matched. Then it checks that there is a semicolon over here, and by checking semicolon over here, it understands that this is, it means there is a or part, and it will go in the forward direction further only if so far the answer that it has got is false. That means the if part is false, and that is why it is going to the else part. But right now, before semicolon, both the predicates have turned out to be true. So as a result, forward mapping stops as it notices semicolon, and it notices that so far entire result on the left hand side is already true. So it does not go to the else part. If part is true, so it does not go to the else part, which is there outside after semicolon. It does not go there. And now it does something called as backward mapping. So as it comes back to the left hand side, it takes along with it the value of x, that is Lx, value of y, that is t naught, and it substitutes x with Lx and y with t naught, and then it returns this true. So as I have already told you, who finally gets the value as Lx, and as a result, in the answer that you saw, it first told you that who weights t naught, it is Lx. Fine. Now when you press semicolon here, it means that you are not satisfied with the answer. I want any other alternate answer. That time I forgot to write that. You all didn't tell me that I missed liked, but it would give me the same result. Just see. Okay, comma. Okay, I asked the same question here. Who weights t naught? Now, it gave me the answer as true. Why? In the previous code that we have written here, likes query was missing. This was missing, correct? And now I have introduced likes query, correct? In the previous code that I wrote, when you compile that code, it gave you who weights t naught, Lx, Peter and John. Okay? Because when you don't write means that it is enough for x to be man, it is enough for y to be woman, then that x weds y. But now I have introduced another predicate that x should be woman, x should be man, y should be woman, and x should like y or y should be wealthy. Okay. Now the answer that you have obtained is true. Who weds Tina? The answer is true. Why? Okay. So let's see the code now. Okay. Yes. Because although Lx, the first variable value, Lx is a man, Tina is a woman, but does Lx like Tina? This was false, right? See here, this was false, correct? Now, if the first stuff is false, it will not return the answer false. It will still try the else part that is there after semicolon. When it comes here, y is wealthy, Tina is wealthy, this is true. But as it gives you answer here, as it comes back, since it has rejected the first half, the value that was contained in x, which is Lx, is lost. Are you understanding? See, it rejected the first part, it was false. So as it went to the else part, whatever assumptions that it made in the if part, that is x was assigned as Lx and y is Tina, y is anyways Tina because from the left hand side Tina has come. But Lx was set only on the right hand side, if part. So when this if part was rejected, the value that was assigned to x, which is Lx, is now no longer true. And when you go to the second part, else part, y is Tina, that is true. So answer is true. But when it comes back to the left hand side part, weds x comma Tina is true. But is it understanding what is x? Has it got any value for x variable? No. And as a result, it does not give you the answer of what is x. Rather, it only says that it is true, because ultimately it has given answer as true. Understanding? Now, if you want this to happen, this is not how the program should behave, correct? If you want this to happen, then you add code here. If x is man, if y is woman, and if x likes y, then it will return the value of x and y. And here also you can say that if particular x is man and particular y is woman, and y is wealthy, I have copied the same thing. So whatever is there in the if part, the same thing I am pasting in the else part also. Only one thing is different. Here there is likes and there is wealthy. Why I have done this? So that x and y both should get propagated in the else part also. You will get answer as true, but you will not get the substitution of x. Right? So now I have copied the same thing. Man x, woman y, woman wealthy. So how will you read this now? How will you read this? X weds y, if and only x should be man, y should be woman, and x likes y. Either this is the case, or x should be man, y should be woman, and y should be wealthy. Now there is completeness. And now you save this code, okay, and you compile the program. Now you try to run this program and see what happens. Who weds Tina? Now it tells you Lx, and it does not give you answer as true. Actually it is Lx and true, okay. But there are more people, as I was talking to you, there are more people who would like to wed Tina because Tina is wealthy, right? So you press semicolon. Peter also, John also. Got? So with this example, now so this is a complete code. What I have told you finally, that's a complete code. So whenever you have OR, remember the variables which you are taking on the left hand side, try to propagate the same variables on the right hand side. If not, you know what will happen. you will ultimately get the answer as true, but the substitutions will not happen. Getting it? I ask you one question now, because we still have time, so I can continue. I ask you one question now. Whenever you write a program, say C program, do you expect this kind of answers? Suppose you had written C program for this, it would have nicely printed, the following people are interested to wed Tina, Alex, Peter and third person. It would not have given you who equal to Alex, then you write semicolon, who equal. This is not the way, right? So how can we write such kind of programs? Okay, so I will just modify this program which I have written, and to modify this program I will require few things. Okay, so in one shot I will show you all these predicates. Okay, so I will be using these predicates. First, I will use something called as write predicate. This write predicate will print the name on the computer screen. I will use another predicate called as NL predicate, that will take you on the new line. And instead of, see, that semicolon means you are rejecting the answer and you are asking for the alternate answer, right? So that instead of external trigger, I can do it implicitly by using another predicate called as fail predicate. So whenever this fail predicate is introduced, no matter, maybe so far all the predicates before this fail, all of them are true, by writing fail, you are purposely making all this fail. You are forcing the left hand side to fail, so that another iteration occurs. Okay? So, how can I? Okay? We will try to use this on a simple this first, and then we will use for Tina, program Tina. Okay? So, I just told you say cakes are delicious, and say only two things are there, pastries and cakes are delicious. Okay? And then further I say likes Tina comma X if and only if that X is delicious. That's it. This is the program. Okay. So cakes are delicious, pastries are delicious, and I am saying that Tina likes X if that X is delicious. I save this program, and now I compile the program and ask the query see how it answers. It gives you cakes, and then semicolon, it gives you pastries. Now I will change this output to the one wherein it will only print cakes, pastries in one shot. You don't have to press semicolon. Okay, and it will not print it as what equal to cakes, what equal to pastries, rather it will only print cakes, pastries. That's it. Okay. So let's modify the program. The very first thing is, so what food Tina likes, correct? So if I find that X is delicious, what I am going to do? I am going to write that X using write predicate. I am going to write that X. So it will write on the computer screen the food that is delicious, comma, and next I will take you to the new line. So you will see the next line being printed. Okay, comma, and then I will say fail and press dot. Okay, and then I will save this program and compile it. Now can you see this? I asked the same question, likes Tina X or what? It directly gave me cakes and pastries. I had to, it did not tell me X equal to cakes, X equal to pastries, nor it asked me to press semicolon so that it gives alternative. And then notice that it printed something called as false in red color. Okay, that is because I force something to become false. Just see how this program works. Check. Now the query that you asked is what food Tina likes. So likes Tina comma what? This is the query that you asked. Likes Tina comma what? Okay. So it tries to match this predicate. Okay. Now for this thing to be true, the right hand side has to be true. So in order to make this true, it tries to associate, it tries to match this delicious with already existing entries. So unification algorithm says that this one can become true only if it matches with the first delicious where X is replaced with cakes, and that's how X gets the value cakes. Substitution theta, correct? This can be matched with the already existing fact only if substitution, that is X, can be replaced with cakes. That's how X gets the value cakes. Then it comes here next and it cakes on the screen. So write is a special predicate. See the blue color, it's a keyword. So write predicate, it prints whatever is written inside onto the computer screen on that shell. So it prints cakes. Further, new line predicate is called, so that it takes you on the new line, and then I am calling fail predicate. So far before fail everything was perfectly true, correct? And now I am forcing this result to be false. So when I force this result to be false, now automatically Prolog understand that I have to come back, backward chaining, on whatever values that I had taken earlier, they have to be rolled back, and I have to check whether there is any other alternative. So it rolls back. Okay. So the value of X which was assigned to cakes, it is unassigned. It comes here, and now again it goes here and tries to take the value of X, not cakes, but it checks whether is there any other predicate that value it can take, right? And then if not this, then it tries to match pastries, and X is taken as pastry. Then it comes here, it tries pastries. You are already on the new line, so you will write pastries there, print. Okay, then print X here, then new line, and again fail. So it again rollbacks. By this time two entries are already printed. Is there any third thing which is delicious mentioned here? No. So as a result, the fail predicate acts, and ultimately the right hand side is fail, no? So it prints the result and finally it prints fail. Got it? So these are the two predicates, right predicate and fail predicate. Okay. Now I won't be writing any programs, rather I will show you the written programs. Okay. Now just this program, cats 1 2 3. This program I have used to show you something called as not predicate, which we tried to use in a wrong way and we saw that it gives you problem, right? Now this is a simple program. First of all, you can take down, consider the following sentences, take down. This is the next one that you are going to write on your file. Represent the following sentences. Represent the following sentences. In Prolog system. First sentence. Sheru and Kitty are cats. Sheru and kitty are cats. Second sentence, kitty purrs, P-U-R-R-S. What is the meaning of purrs? Whenever you have cat, right, like this, it produces some sound. That's called as purrs. So kitty purrs. And Sheru lives in jungle. It is one sentence. Kitty purrs and Sheru lives in jungle. Next sentence, tigers live in jungle. Tigers live in jungle. A cat is a domestic cat if it purrs. A cat is a domestic cat if it purrs. A cat is a wild cat if it lives in jungle. A cat is a wild cat if it lives in jungle. Cats that purr do not bite, or does not bite, sorry. Cats that purr does not bite. Cats living in jungle bites. Cats living in jungle bites. The next sentence is tricky. Okay. Cats that bite does not like to be cuddled. Cats that bite does not like to be cuddled. Okay. Ask the following queries to the Prolog system. Ask the following queries to the Prolog system. First query, is Sheru a domestic cat? Is Sheru a domestic cat? Second query, does kitty bite? Third query, who likes to be cuddled? Who likes to be cuddled? Among the two cats, please. Who likes to be cuddled among these two cats? Okay. So don't read this, you try it on your book or wherever. Just try. What is the first query? No, query. It's Sheru or domestic cat. Okay, the student just check. Just see here, because we are not having much time. First sentence, kitty is a cat. Second, Sheru is a cat. Please look at the screen, all of you. Then you can write. Just look at the screen. Sheru is kitty is a cat. Fine. Then kitty purrs. Sheru lives in jungle. Tigers live in jungle. So if S is known to be tiger, okay, S is a tiger, a new fact, if and only if that S is known to be living in jungle. So tiger live in jungle. Okay. Then I have given you that cat is a domestic cat if it purrs. Now purrs is already there, cat is already there. So they are coming on the right hand side. If X is a cat and if X purrs, it means that X is domestic cat. Okay. Similarly, live in jungle is already there. So if Y lives in jungle and if that Y is cat, new fact is that Y is a wild cat. This much I think everybody by now must have understood. Now what I want you all to see, this is the next one. Now cats bite, cats that purrs do not bite. I have represented this in a contrapositive way. Okay. Now see what I have written. Let z be a variable. Let z be the variable representing the cat which binds. So z bites is true if z is a cat and that z purrs is false. That means z does not purrs. So you see here, when I use not predicate as the right hand side of any production, any rule, then it is printed in blue color. Is there any other way how we can write this? Can you tell me any other way of, you can, okay, you just ignore this sentence here. Cats that purr does not bite. Okay, you would have written it like this. See, not bite z if we know that z is a cat and purrs z and dot. Students, please see this sentence which I have written. Many of you all might see that, feel that, sir, why you have written this as a contrapositive sentence? You would have written the sentence that I have written below, where not is highlighted with yellow color. The sentence is cats that purrs does not bite. So on the right hand side, if you see here, if z is a cat and if z purrs, that means cats that purrs and that does not bite, right? So on the left hand side, you are bound to write not predicate and then in bracket bite z. But when you ask query, who does not or who bites? If you ask the query, who is that cat which bites? What will happen? When the unification algorithm tries to match, it will not find a predicate called bite, because bite is encapsulated within another predicate called as not. So although bite predicate is within not, it will not be able to find that bite and it might give you the answer as false. And this is a problem that happens when you try to use not predicate on the left hand side, because when you try to use it on the left hand side, the left hand side predicate gets encapsulated within this not, and the Prolog system will not be able to see that left hand side predicate, rather it will only be able to see the outermost, that is by not, and you will get all wrong answers. Fine. The same thing happens when you try to use not predicate in an isolated manner that we saw in the previous case, and that is why Prolog tells you that marking, that highlighter yellow color tells you not the syntax error but the logical error. Koita? It is telling you there, highlighting, it is telling you have not used it properly. But now the question is, I have given you exactly the same sentence. If not like this, then how else I can represent the sentence? Now use your contrapositive style of thinking. Cats that purr do not bite. This is given, right? Which means cats that do not purr bite. So exactly the same thing I have written on top. Z bites. See this sentence. This is the contrapositive way of writing the same thing. What I have written? Z bites is true if and only if I know that Z is a cat and that Z does not purr. Meaning it's same, but by writing this not predicate, I am trying to have it on the right hand side. Correct? Which is the proper way of usage. Got it? Sure. So I will erase this sentence. This is not required. Now same thing I have done with the last students. See the last sentence. The cats that bite do not like to be cuddled. Purposely I had given this sentence also. The cats that bite do not like to be cuddled. Same way you would have written on the left hand side, not like cuddled. You would have written and you would have got wrong answer. I have represented the same thing in a contrapositive way. What is contrapositive way? Cats that do not bite, they like to be cuddled. The other way around. Right? So when you are writing this for practical exam, notice whenever not is depicted with blue color, know that you have used it properly. And if there is yellow color marking, it means you have not used it properly. That means syntax wise you are correct, but you might not get the answer. Okay? So you can write this and execute this. Now what you can do is, Sandra ma'am, before you go, Sandra ma'am will tell her to give the same software that is installed. You take it, install it at home. It's very simple. And these programs you can try. In fact, the programs which you are supposed to write for the practicals, in that, I will give you a Word document. Better? And then try the same ones. Okay? Okay. It is 1:15 we are leaving. Please, can I show one more program? Last program. Acha, chalo. Now, this is what I wanted you all to understand in Prolog. So now at least you have got the basic. Now you have to try. I will post a video which will be hardly 30 minutes video, in which I will explain you the expert system that actually you are going to write. So far you have not written. I will explain you that expert system by writing the program and showing the output, and that's it. So same expert system, then you can put it in the file. Okay? For semester exam, 15 marks Prolog program will come, remaining marks Python program will come. Python, although there are 7 programs, you tell me which 5 you want me to ask. I will ask you this during the Viva. Okay? Now, your file submission dates are 12th and 13th. Your practical file submission dates are on 10th and 12th and 13th. Okay? On these 2 days, mostly, 12th only you come and get the file certified, because 13th I will also take your Viva, term work Viva. First only I will tell you, on 13th you have to get your tutorial notebook fully complete and submit it to me. You cannot collect it back. Okay? Your assignment should be fully complete. Today night I am giving the assignment number 2, that those are 3 questions. Okay? So those 2 assignments you have to put in the file. So file, assignment, tutorial, if they are complete and if you are submitting, you are straight away getting 10 marks, passing marks out of 25 in term work. Now the remaining marks I will be making oral on 13th. I will make some 4 or 5 students sit together and I will ask some questions. Questions will be in on AI topics. They will be on your programs that you have done. Okay, for me to know that you have really seriously worked on those programs. So before coming for that, please go through your programs and know the programs and the output. Okay? So term work marks will be based on your term work submissions and the knowledge. Otherwise what will happen? You only submit, copy and submit. Why should I give you full marks? There should be some reasoning. So maybe some assignment question that you have written, I might ask you, tell me how you have done this. So based on that, remaining. Passing, everybody will pass. You submit it on that day, you will pass. 10 marks. But 10 marks won't take you anywhere. You will require more marks. And without answering Viva, I will not grant the term. So that I am giving you on 13th. By 13th evening, I will read. The file goes to Raman for keeping. So that also you submit. On 13th you submit. If you feel that something you might require to study for semester exam, better you take photograph and give me the book, because book correction I am not doing now. Okay, so you will have to collect the book maybe in the next semester. Okay, because that marks and all that I am doing for NBA, and NBA file so far I am not touched. I will be touching it after the tech mania. Till then, your file, your booklets will be with you. The tutorial marks which I have put, they have got nothing to do with your semester marks. Semester marks are different. Your oral is there. 10 marks I have already given for passing. And remember, for term work, mostly your marks will be somewhere between 25 hardly people will get 24 to maybe 20-21. I don't want you all to go lesser than 20 marks. But then if you decide that I will take less than 20 marks, I can't, किती तरी तोंड आन्सर करपाक जाय for the oral. Done. Okay, thank you.